Okay, so I'm going to talk a little bit about error and power. So a couple of things to remember. Type 1 error is when we reject the null hypothesis. That's in our hypothesis test. But it turns out in reality the null was actually true. That is type 1. And we use the symbol alpha to represent the probability of a type 1 error. And that is the same alpha that we use for the level of significance. So they are the same thing. Whatever you set as your level of significance is going to be the probability that you make a type 1 error. A type 2 error is when we fail to reject the null hypothesis, but it turns out in reality, in real life, the null was actually false and the alternate was true. So that is a type 2 error. We use the symbol beta to represent the probability of a type 2 error. Power is the probability that we conclude the alternate is true when it really is true. So there's two parts to that. Probability that we conclude the alternate is true when it really is true. Now, power is found by subtracting 1 minus beta, which is the probability of a type 2 error, or in other words, type 2 probability plus power will equal 1, is another way to think about it. A couple ways to increase power in a test. If we know we have an alternate hypothesis that is true and we want the best chance we have of concluding that it's true, one thing we can do is increase our alpha, which is the level of significance or the type 1 error. Increasing type 1 will just by default decrease type 2, and that's going to increase power. We can also increase sample size, or n. This makes our standard deviation much smaller, and that's going to end up decreasing both types of error and in turn also increasing power. And we could also increase the effect size, basically make the new thing as better as it can possibly be. So if our alternate hypothesis is that mu is greater than 50, well, if we make it to where the true mean is like 85 or 90, that's going to be better than if the true mean were 60. In both of those cases, it's greater than 50, which is our null hypothesis, but we have a better chance of proving that it's true if it's a lot greater than 50. So that's kind of where that comes from. Be careful. I think the biggest mistake I saw on a question regarding power and error on our practice tests, type 1 and type 2, the alpha and the beta probabilities do not add up to 1. So it's not like you can find type 1 by doing 1 minus type 2, or type 2 by doing 1 minus type 1. They do not add up to 1. They do act in inverse of each other, so as type 1 increases, your probability of type 2 is going to decrease, and vice versa, but they do not add up to 1. Remember, beta helps us get to power, because beta and power add up to 1, but alpha, type 1, and type 2, beta, do not add up to 1. So, real quick, little side note.